Alright, ladies and gentlemen, this is going to be the next video on water and pH, and specifically going over acids, bases, and pH. Let's get started on this next video. So what we're going to do again is we're going to review what a polar molecule is. Polar molecule is a molecule that has a slightly positive and slightly negative region. Remember, oxygen has an overall negative charge, and at the bottom, the two hydrogens have an overall positive charge. You should know this by now. Please make sure we understand that as we move into this video. Now, water is going to exist as H2O like we've been going through and talking about, and it is a polar molecule. However, what's key for us to understand here is this H2O's overall charge is going to be neutral. It has positive and negative regions, but the overall charge, the positive and the negatives, will go through and cancel out. What I haven't discussed with you yet is water can also exist as hydronium, or it can exist as this hydroxide. So what it's going to do is the water is going to exchange these hydrogen atoms, and when it does that, hydrogen has an overall positive charge. So if we look at the hydronium, it's going to exist as H3O+. This is going to have an overall positive charge because of that extra presence of that extra hydrogen atom. Now, in the absence of that hydrogen atom, and we are losing a hydrogen from this, what we see is we have OH-, which is just one oxygen and one hydrogen atom put together. And when we see the absence of that hydrogen, the overall charge is going to be negative. What's key for us to understand from this slide is water's going back and forth between H3O+, or H+, and OH-, and it's exchanging these hydrogen ions, or these hydrogen atoms, at different rates. So what we're going to look at for pH is the rate and the ratios at which these hydrogen ions are going through and being exchanged. So let's go through and look at this. pH is going to be a measure of the ratio of hydronium to hydroxide ions in solution. So what we're going to do is we're going to look at the ratio of H3O+ or H+ to OH-. What we can do is we can put that on a logarithmic scale, and then once we have that on that logarithmic scale, what we can do is we can get what we call the pH. So we are measuring the ratio of H3O+ to OH-. That's all pH is. So let's go through and look at this scale here. What we see is in the middle of this scale, we have a neutral pH. That means we have an equal ratio of H3O+ to OH-. It's a 1-to-1 ratio. Now, if I go to the right-hand side of this column, what we see is anything that's basic is going to have more OH- in comparison to H3O+ or H+. Anything that is acidic, we have more H3O+ or H+, we can shorten it, as compared to our OH-. So pH is basically the power of this hydrogen. It's the quantity of hydrogen ions there are in solution, and it measures the relative concentration of H+. We also can call that H3O+, but I'm going to shorten it for the rest of this video to H+. Let's go through and look at this in detail. What we're going to see is acids are compounds that release H+ into solution. There is more H+ in that solution. If we were to zoom in on our stomach here, what we're going to see is if there are more of these H+ as compared to these OH- molecules, then the solution is going to be acidic. So in this case, here are some OH- molecules here. And then what we're going to see is we have a larger ratio of these H3O+ or these H+ ions, and because of that, the solution is acidic. All pH is a measure of the ratio of H+ to OH-. Now, if we want to go through and look at a base, well, bases are compounds that release OH- into solution. We can see the more OH- we have, the more basic the solution or the more alkaline it is. So if we look at the diagram here, we only have 3 H+, we have a ton of OH-. Because there are more OH- as compared to our H+, what we see here is the solution is going to be basic or alkaline. So let's go through and make sure we understand the two and compare them against each other. Acids are going to have more H+ as compared to OH- ions in solution. They also are going to have a pH of less than 7. The lower the number, the stronger the acid. It's on a logarithmic scale, and we'll look at that. An example of a strong acid would be hydrochloric acid, produced by your stomach to go through and digest food. If we compare that to a base, Well, bases are going to have more OH minus than H plus in solution. They have a pH of greater than 7. The higher the number, the stronger the base. An example of this would be like a basic solution might be used in soap making or maybe toothpaste. More H plus, it's an acid. More OH minus, it's a base. Now, if we're interpreting the pH scale, what's important for us to understand is it is a logarithmic scale. So what does it mean if it's a logarithmic scale? So the pH scale is logarithmic, meaning that it increases or decreases on an integer value based on the concentration tenfold. So it's a log scale, so it's going to increase or decrease by powers of 10, and a pH of 5 is 10 times more concentrated than a pH of 6. That's in terms of the H plus concentration. So again, it's logarithmic, so as you go up the scale, we're going based on powers of 10. And since we're moving through those powers of 10, each subsequent acid, if we go from 6 to 5, is 10 times more potent. 6 to 4 would be 100 times more potent. 4 would be 100 times more potent as an acid. It's going to move in the opposite directions we're going through and looking at bases there. It's a logarithmic scale, increasing in concentrations tenfold. Now, if we want to interpret this pH scale, we're going to interpret it based on a pH of 7. 7 is going to be neutral. We have an equal amount of H plus to OH minus. If we move down to the left, anything between 3 and 7, that's going to be a weak acid. Anything between 7 and 11, that's going to be a weak base. Anything between 0 to 3, we're going to have a strong acid. And anything from 11 to 14, we have a strong base. So we're moving left or right on the scale using the number 7 as our neutral middle zone. All right, so let's go through and make sure we review this and understand what we're looking at. Acids are compounds that have more H3O plus in the solution, or they release that in the solution. Bases are compounds that release OH minus in solution. There's more OH minus as compared to H plus when we're talking about bases. Using the logarithmic scale, we can determine the strength and weakness of acids and bases, the scale that we see here, to determine what its pH is. All right, so did you learn? Well, did you learn a couple of things? Did you learn how the molecules of water exist? Did you learn about what pH is? It's the ratio of H plus to OH minus. And then did you learn about how we go through and measure pH and use the pH scale to go through and look at solutions, how acidic or how basic they are? This is going to be the end of the video. I will see you all in class tomorrow.